I want to talk briefly about dates and times in R, which is it's a very special topic and could require a lot more time. But I'm just going to talk a little bit about how R represents dates and times and how you can use them in kind of arithmetic and data analysis types of computations. Um, so R has a special way to represent dates and times, and they're represented using special data classes. So in the past, we've talked about different data types like lists and character vectors and numeric vectors, and so this is just another type of data on top of those kinds of classes. So dates are represented by the date class, and times are represented by two separate classes, the POSIX CT and the POSIX LT class. So dates are basically don't have times attached to them. They're just they represent a day in a year in a month, and the kind of you can think of them in a kind of a year, month, day format. So, for example, this date is 1970 January, and then January 1st. And so internally, the dates are stored as the number of days since 1970 January 1st. That particular detail is not very important, but in case you're wondering, you don't how R actually does calculations based on dates. Times are stored internally as the number of seconds since 1970 January 1st. And so that's, again, another underlying detail that's not very important, but it may be useful to know sometimes. So the way dates in R work is you can take a character string, like this following 1970-0101, and convert it into a date using the as.date function. That's probably the most common way that you'll begin working with dates. And you'll notice that if you print out this object, you'll get something that looks like a character string. Now, it's not actually a character string, but it will print out that way because there's a special print method. Now, if I unclass the object here, you'll see I get the number 0. Remember, because the dates are stored internally as the number of days since 1970 January 1st. And since 1970 January 1st, 0 days from that point, you'll get 0. If I input January 2nd, 1970, then you'll see that underlying is represented as the number 1 because that's 1 day after 1970 January 1st. If you had a date that was before 1970, then they would be represented as negative numbers. But that's just for your little background. You don't have to worry about the underlying representation. Ultimately, what you need to know is that dates are stored as objects of the date class. Times, on the other hand, are represented as two possible types. One is called POSIX CT, and the other one is called POSIX LT. So POSIX is a family of computing standards for how things should be done on certain types of computers or how data should be represented. And so there's a family of standards for how to represent dates and times, and so POSIX, that's part of the POSIX standard. So in the POSIX CT class, times are represented just as very large integers. And so it's a useful type of class if you want to, say, store times in a data frame or something like that, because basically it's like a big integer vector. POSIX LT stores a time as a list underlying, and so it stores a bunch of other useful information about a given time. For example, what's the day of the week of that time, what's the day of the year, the day of the month, or the month itself. And there are a number of generic functions that operate on both dates and times that you can use, such as the weekdays function tells you what day of the week a given time is or a given day is. The month function tells you what month that date or time is, and the quarters function gives you the quarter number. So, for example, Q1 would be January through March, Q2 would be April through June, etc., like that. So these generic functions operate on objects of class POSIX CT, POSIX LT, or date. So, for example, you can coerce things back and forth between POSIX LT and POSIX CT if you want, using the as.POSIX LT or the as.POSIX CT function. So, for example, the sys.time function here just gives you the current time as it's known by the system, and you can see that when it prints out in a year, month, day format, and then an hour, minute, second format, and then the time zone, which is Eastern Standard Time right now. So you can convert this to a POSIX LT using as.POSIX LT. And POSIX LT, remember, underlying is a list. So you can look at the names of the elements in this list if you unclass it. And you can see that there's an element called seconds. That's the seconds, the minutes, the hours. The M day is the day of the month, which in this case would be 23. The month is just the month you're in. So that's January, and then the year, the weekday, so the day of the week, the year day, which is the day in the year, and then are we on daylight savings or not. So if I extract the seconds element of this list, you'll see it's 11.86, and so this actually gives you the seconds in fractional seconds. So it's 11 seconds and then 0.86 seconds. So that's the number of seconds in the time. The POSIX CT format, you can see, is you can also get it from the sys.time function, and you can see that if I unclass this POSIX CT object, I get this very large integer because that's just the number of seconds since January 1st, 1970. Now, if I try to apply the list operator, the $sign, to this object, you'll see I'll get an error because objects of POSIX CT don't have these list elements in them. If you want to get those list elements out, you have to convert it to POSIX LT using the as.POSIX LT function. Then I can get the seconds out. In this case, it's 11.88 seconds. So finally, there's the stir ptime function, which converts dates that are written in character string format into date or time objects. Well, in this case, it converts them into time objects. So, and they use what are called format strings. So here I've got a string that says January 10th, comma, 2012, and then 1040, meaning 10 hour 10 and minute 40. And then I have another string that says December 9th, 2012, 910. So if I want to convert these strings to time objects, I can use the stir ptime function. What I do is I pass it the character vector, and then I pass it a format string. So in this case, and so you'll see all these percent signs followed by letters, and then you can look up what these symbols mean in the help page for stir ptime. So %B means the month, is the unabbreviated month name. %D is the day, then comma, and then %Y is the 4-digit year. Then %H is the hour, colon, followed by %M, which is the minute. And so that's the format of the times here. And you can see that after I call stir ptime and I print out X, I get these time objects that are printed out in the standard format. When I look at the class of this object, you'll see it's in a POSIX LT format, and so that's the kind of underlying list format here. Now, I personally can never remember what those formatting strings are, the %B, %D, %Y. I can never remember what those are, and so I always have to look at the help page for stir ptime to remember what those details are. Now, once you've got data in the date or time format, you can do operations on them, which can be very handy. For example, you can add and subtract dates. You can compare dates. You can see is one date less than another date, or are these two dates equal to each other? So one thing that you need to be careful is that you can't always mix different classes. So if I have X, which is a date object, and then Y, which is a POSIX LT object, if I try to subtract the two, you'll get an error because they're not the same type of object. So but if I convert the date to a POSIX LT object, so I can do as.POSIX LT on it, then if I take the difference, it'll say that there's a difference of 356.3 days between the two. The nice thing about the date and time operators is that they keep track of very tricky things like leap years, leap seconds, daylight savings, and time zones. So this first example here, you can see that, so 2012, it was a leap year, and so there was a February 29th, and so the difference between March 1st and February 28th is actually a difference of 2 days, not a difference of 1 day like it is every other year. Similarly, I can take two times, one which is in my X, which is in my kind of current time zone, and then Y, which is in the time zone of GMT, so Greenwich Mean Time, and take the difference between those. So even though it looks like it should be a 5-hour difference, it's actually only a 1-hour difference because of the change in the time zones. So one of the advantages of using the date-time classes is that it will automatically take care of these kind of irregularities. So now it's just a quick kind of overview of the dates and the time classes in R. So just to summarize, there are special classes in R that represent dates and times and allow you to do numerical and statistical calculations. Dates use the date class. Times use either the POSIX CT or the POSIX LT class. And then character strings can be coerced to either a date or a time class using the stir_ptime function or as.date, as.posixlt, and as.posixct. The other thing to note that I haven't really talked about here is that a lot of the plotting functions will recognize date-time objects. So when you try to plot an object that's a date-time class, it will recognize that object and then format the x-axis in a special way so that it will have a time kind of element to it. So you might want to try to experiment with that a little bit to see how plots change when you use a date-time class.